Good morning and welcome to this Thursday, where we are continuing our discussion on number systems. Now, we have talked about the Roman number system, saw some similarities, some differences, learned some stuff, I hope, and we saw the Babylonian number system. Similarities, significant visual differences for sure, and perhaps more differences than there actually are, it might feel. But they both had value, I argue, to our understanding when we come back to our decimal system. But we're not there just yet. We are moving on to chapter 7. Now, chapter 7 has some smaller parts to it that we can look back when we're done, and it'll take us around 3 days to work our way through 7. It's a little bit bigger. I'm going to look at another number system called the one-hand system. Now, this one, I'm not even going to pretend, is not nearly as sophisticated as the Roman and Babylonian systems. A natural way of thinking is, and especially with some tribes in Africa, I think they took this number system. They didn't have a lot of things to count necessarily. They were nomadic. Based on their needs, they figured, well, we have 5 fingers, so why don't we use that to count what we need to count? It's not much. We need it. We have enough fingers. So the symbols I'm going to change a little bit to suit our needs. It's not exactly how the system worked, but underneath it's the same. So we are going to have a rock symbol, and that's going to represent 1. That's going to be, in our language, 1. Then then they want to represent 2 things maybe, then they'll just draw 2 rocks. 3 things, whatever that may be, 3 days, 3 people, whatever. 3 little rocks, whether you draw it or arrange it or whatever. And 4 in our language will be represented with 4 little rocks. But then, similar to the Romans, they realized that, well, if I have too many of these of the same symbol, it's going to blur together and I can't quite recognize what I'm doing here. So when I want to represent 5, that's a V there, I'm going to introduce a new symbol and I'll use a finger. So it's not a 1, it's a long line. And that represents 5. 1 finger represents 5 rocks. So I'll say here 1 finger equals 5 rocks. But I'm not allowed to write 5 of the same symbol. They felt that would be too much, so they capped it and brought in a new symbol, much like the Romans did. Then if I want to represent 6, I'll have a finger and a rock. 7, I'll have a finger and 2 rocks. And it's very similar, just list all the things under the requirement that I can't have 5 of the same thing. So now I can go quite far. I can, for example, go to 23 by having 1, 2, 3, 4 fingers and 3 rocks. Because each finger is worth 5, right? They're sort of groups of 5. So I can have 5, 10, 15, 20, and then 3 singles. 24 will then be 1, 2, 3, 4 fingers and 4 rocks. If I then want to go to 25, I have to essentially add a rock. However, then I would have 5, and 5 rocks become a finger. But then I have 5 fingers. I need a new symbol. And they have the hand symbol. So that would be 25. 5 fingers, so 5 groups of 5. And I could say here that, what's it equal here? A hand is equal to 5 fingers. But I can't list 5 of the same symbol. I introduce a new symbol. Okay. And then I can keep going. I would maybe do 26, for example, in our language, will be a hand and a rock. So I'm slowly introducing new symbols whenever I have 5 of the latest symbol. Then I need a new one. I only have one rule. Don't list 5 of the same thing. So it's much simpler than the Roman numbers would be. So I can go, how high can I go here? I can go to 100 and 24, I claim. How would I represent 124? Well, each hand, remember, each hand is worth 25. So I could have 4 hands. That's allowed. That'll give me 100. 4 fingers will give me 20. And 4 rocks would give me another 4, 124, by just listing everything. But now if I have 125, I'm in trouble again. I would add a rock because I'm adding 1. It's 1 more. Then I would have 5 rocks. That's not allowed. That converts to a finger. 5 fingers convert to a hand. So I would have 5 hands. And that's where I need a new symbol. And I think they brought in a symbol like a foot, like that. Now you see the pros and cons here. It's simple, easy to understand, as long as your numbers are low. If your numbers are small, no problem. And that was their situation. They didn't think that, oh, if our group grows, our community grows, we get we're more successful, we get more stuff, we're going to have to think of bigger numbers. We're going to have to introduce new symbols very often because we're counting in groups of 5 essentially, and it's going to fall apart. But they didn't have that need, so we're not going to really be concerned with that. We're going to stick to nice, fairly small numbers because that was what it was designed to handle. You'd have to, for 5 of these foot symbols, you'd have to introduce more symbols, but we won't do that. I don't actually know what the next symbol is. I think it was an elbow or something, but it's sort of, it gets a little silly once your numbers get too big. So we're going to stop at the foot symbol. Okay. How does that feel so far? It's trying to be more basic because that was their need. Their needs weren't too sophisticated in terms of numbers. Any questions so far? Okay, so now we have exercise 7.1. We have a new number system. So that means we're going to do our conversions back and forth. Now I'm just going to put this on the other screen so I can more effectively copy it. Let's see where we're at. I'll leave that, make a new page. All right, so we have exercise 7.1. We have number 1, our 2 conversions, a hand and 2 fingers. That will be, I can list them. I could say it's 25 plus 5 plus 5. So I get 35. Really very little to it. I'm just trying to remember what each symbol means, and then I add them all up. There's nothing fancy like the Roman subtractive pairs or nothing like that at all is going to happen here. It's simply I can't have 5 of the same symbol in a row, and that is it. So I have a foot, which is 125. I have a 25. I have a 25. I have 111. Or I can just say 4 if you want. Right? What do we get there? We get 175, 179, it looks like. So it's designed to be simple, and hopefully it succeeds, as long as my quantities are small. And even these quantities might be a little bit too much. Maybe you want to keep track of how many days it rained in a month or something like that. The numbers aren't very big. So let's have 3 feet and a finger. So that is a 125 and a 125 and a 125 and a 5 to give us 375, 380. All right. So hopefully you agree that that direction for the conversion isn't overly complicated. The other direction, I don't believe, is much more complicated either, but usually going from decimal into this more foreign-looking number system is sometimes the one that requires a little more thinking. So I guess it's the same here as well. But the benefit is that our number system is going to be super small in terms of quantities that it's going to handle. So that makes it easier to just figure out. So I want to start with the largest symbol, right? Now I have a 5 symbol, I have a 25 symbol, I have a 125 symbol. So I don't have that many options. I can definitely use a hand. I can use a hand. That accounts for 25, and I have 12 left. So I can use a couple of fingers for 10, and then a couple of rocks. Let's make the rocks nice and big so they're easy to see. So I'm just starting with the biggest symbol I can get in there. And then I see what's left and just start backing it in. Not much else to it. But let me know. Feel free to interrupt if you have any questions. Then we have 128. Now I want to pack in, I can pack in a foot. Now maybe I want to keep track of this, right? Just like some little numbers in the bottom here. So I can keep track of what I have already used, how much, and I see I only have 3 left. Well, 3 rocks will do that. So a foot and 3 rocks. Trying to be simple, and I hope that it is. Because our numbers, even this 526, is going to be on the high end for the one-hand system. What are they going to count? That is 500 things. A nomadic tribe might not have the need to keep track of quantities that large. So it fits the needs of the time and the civilization or the group. So what is the largest one I can pack in here? Well, I can definitely get some feet in here. I almost said elbows, feet. So 3 would be 375. 4 feet would be, well, remember each foot is 125, right? So 4 of these feet would be 500. Then I see, okay, I have 26 left. That's a one. I can get one hand in there for 25, and only one will be left for a rock. So yes, if the numbers were bigger that I had to convert, then certainly it's going to require a more structured method, perhaps, to keep track of the symbols and what's accounted for and so on. But luckily, that is not going to happen. So those are the two conversions that we now have with our one-hand system. And again, feel free to interrupt me if you have any thoughts or questions. Chapter 7 is a little bit bigger, so I just want to make sure I get to everything I want to get to. So, like I said, there are pros and cons to this number system. It's basic, but it was designed to be basic. So it can't be extended efficiently for a large civilization or a large community with large numbers and trading and taxes and all kinds of things. It's going to show its limitations very quickly. But it is quite simple and quite elegant in its design. So as things grow, as numbers increase, they didn't want to just abandon this necessarily. We want to hold on to the good parts and just realize the flaws. So let's say here, we can't effectively introduce more and more symbols, right? People are going to forget. It's just going to get really long. You see some of those Roman numbers are super long, and it gets a little tricky. But luckily, people noticed something. Like, look, if, for example, you take, let's say, a foot, let's say you take 2 hands, let's suppose you don't have any fingers, and let's suppose you have 4 rocks. Actually, I'm gonna mix it up. No, it's fine. Let's do it like that. Let's suppose you have this. I'm just creating that space now. So normally there wouldn't be any spaces. You would just list all the symbols. Okay, great. But if we now space it out and realize that there are always a certain number of foot symbols, there are always a certain number of hand symbols, there are always a certain number of finger symbols, and a certain number of rock symbols. Is it really necessary to list the symbol and show the symbol itself over and over and over up to 4 times? Or could we instead just say how many rocks, how many fingers, how many hands, how many feet? Because then if we say there are Sometimes 0, sometimes 1 of the symbol. Sometimes maybe there are 2 rocks and 2 hands. The 2 is now consistent in between the symbols. And my options for, I'll go back by 4. My options for how many there could be are quite limited. In our language, our options are 0, 1, there could be 2 of a symbol, there could be 3, there could be 4, there can't be 5, because then it would roll over to the next symbol. So these are our only options. Now, if we agree that from right to left, the place will represent the number of rocks, the very next place will always represent the number of fingers, the very next place will always represent the number of hands, feet, and so on, then we don't really need to draw feet, hands, fingers, rocks. We only need to make symbols for these quantities, these 5 quantities, 0 to 4 we'll call them, and we can stop drawing these pictures. So now we need to make symbols. So now through history, these evolved. Initially they were just a couple of lines, maybe a 2 had a couple of lines, and I'll show you a picture. Let me go back to my book here. The symbols that they used evolved over time. Where is it now? There it is. First century, see just lines, horizontal lines, and then they got a little bit more elaborate. 9th century, and then depending on the area in the world, they split up into different symbols as well, and eventually those evolved around the 16th century to symbols we might recognize today as pretty much the ones that we use, our decimal symbols. But that happened slowly over time. And these that we ended up with are just symbols that came from how people evolved. It could have been any other symbol. So to emphasize that, I'm going to take this 11th century snapshot to remind myself that these are just symbols, because I don't look at my numbers in the same way. I don't look at them as symbols. I look at them as something more, and they're not. They're just symbols that people have decided to use, and I just assumed that's how it always was. It wasn't. It just changed, and it's interesting. It's an interesting topic of study to ask how or why did this way of writing change across the centuries. Interesting enough. We're going to take this snapshot here, the Sanskrit Devanagari, and our symbols will then be to remind us that it's just symbols and what these symbols are used for. 4 is going to be that symbol. 3 is going to look a little familiar. 2 will be fairly familiar. 1 may be less so. And the 0, the theory is that they put a larger rock to be the empty place symbol. And then when they removed the rock, it left a little indentation, and that's where the 0 symbol came from. Probably the one that stayed the most consistent. Okay, so now if I want to represent this one-hand system number with my Devanagari symbols, it will always be, the places will always represent feet, hands, fingers, rocks. I just need to say how many there are. There is 1 foot. There are 2 hands. There are 0 fingers, and there are 4 rocks. Now I'm not going to use the words of that time as well. We'll stick to our English words. And hopefully the symbols are enough to remind me. It still looks a little foreign, reminding me what's actually happening here. I'm not comfortable. Well, I don't want to be comfortable. That is the whole point. I don't want to be comfortable because as soon as I'm comfortable, I stop thinking. And I want to think about how this works. Okay. So, let me just check what our examples are so I don't miss one. We've done 7.1. So now we see here that's going to be our symbols. Maybe some require some practice. The biggest risk I find is you don't want the 1 and the 2 symbol to look too similar. So just make sure that they are different. So we want to convert. We want to convert. Oops. I should probably put it on the other screen so I can just copy it, right? So we're in 7.2. Let us write that. Exercise 7.2. Number 1. One-hand system to the Devanagari symbols. First one, I will copy it, a hand and 2 fingers. Now keeping in mind, it's always going to be longer line here. Right to left, it's always going to be number of rocks, number of fingers, number of hands, and so on. If one isn't there, I still need to indicate that because it's now crossing over to a place value system. So we will say that there is 1 hand, there are 2 fingers, and there are 0 rocks. Again, feel free to interrupt if you are not sure. B, we have the following. They're actually both the one-hand system. There's just different versions in history as it evolved to be more efficient in what it's trying to do. So now I'm going to have 4 places. I'm going to have a 4 place, or if you will, 4 digit, 4 symbol number. Using this more sophisticated version of the one-hand system by just keeping track and saying there is 1 foot, there. What did I do here? Oh, 2 fingers, right. Now I'm doing hands next. 2 hands, no fingers. 2, my 2 looks very, very decimal, very modern. Let's give it a little more curl to it, I guess. Yeah. 2 rocks. So the places and what the places are keeping track of, that is the constant thing. The places are always keeping track of rocks, fingers, hands, feet from right to left. I just have to then say how many of each of those there are. So the next one is 3 feet and a finger. So I'm going to have a 4-place representation. 3, whoopsie, a little more curly there. Come on, curl, there we go. 3 feet, no hands, 1 finger, and no rocks. Just listing how many of each of the original one-hand system symbols there are, because that's all I need. If we agree what each place is counting and keeping track of, then all I need to know is how many there are in that place. Number 2. Number 2. Again, please don't wait for me to pause and ask, are there any questions? You should by now feel free to interrupt at any stage. Otherwise, I cannot tell how you feel about any of this. Now, we are converting the other direction. So in A, we have the following number. So now I remember, okay, let me write arrows underneath here. This will represent the number of rocks. The next place from the right will represent the number of fingers, or keep track of it rather. The next place will represent or keep track of the number of hands. And therefore, I am now converting to the one-hand system. I have one hand, I have 4 fingers, and I have 0 rocks. But by keeping the symbols a little less familiar, some cultures, some schools, they actually still learn these symbols. They're not that far removed from us. But for most of us, they look a little unfamiliar. We don't have many of them. It just keeps us on our toes to really think about what is happening here. It needs to look different for us to really think. Then to B, we have the following Devanagari representation. Still the same number system. It's just a more sophisticated way to do the same thing. Keeping track of the rocks, keeping track of the fingers, keeping track of the hands, and I only have 2 hands. There's nothing else. Just a bunch of zeros. And the last one is a little bit longer. We have the following. That's a 1. The 1 and the 2 look very similar sometimes in the font, so please be careful and look at the difference between. Put a little curl in the two so it can stand apart from the 1. So I'm gonna have rocks, fingers, hands, feet. Ooh, it's a big one. I'm gonna have 4 feet. I'm gonna have 4 hands. That doesn't even look square. Come on. I'm gonna have 3 fingers, and I'm gonna have a rock. So you see here already how much more efficient this updated version is. That the old way of drawing all the symbols can give me a representation that's unnecessarily long. By just thinking about it in a more sophisticated way, luckily people realize this at some point in time, to just keep track of how many there are of each symbol and use symbols for that instead of the actual symbols, and convert over to a place value system. Much more effective, which eventually, of course, led to our decimal system. Now here, we keep it a little different with the symbols, sure, as well as counting in groups of 5, really, right? Because here we say the number of rocks, it's really the number of ones. The number of fingers is really the number of groups of 5. The next place, the number of hands, really the number of 25s. And next one, number of feet. Well, a foot is 125, so it's really the number of groups of 125. So we're counting in 5s. 5, 25 is 5 squared. 125 is 5 cubed, and 1 is, of course, 5 to the 0. So it's actually quite similar to the Babylonian system. In a way, it's a little better in that our group size isn't that big, so it's easier to handle. And we have at least more symbols to give us some variety, so that there aren't clusters of symbols, but each place is a single symbol. But we're counting in fives, and we can call this a base 5 system. Base 5 system. So now when we look at our example 7.2, we've done number 1 and 2, going from the old original one-hand system to the, comparatively speaking, much more modern Devanagari base 5 place value version of the same underlying system. We can then, excuse me, convert between the, what was it, 16th century? No, that was modern, right? Where are we now? 11th century. 11th century version and our modern symbols, where these symbols slowly evolved to the ones we have today. However, in this system, we are still counting base 5. So when we convert, we remember we convert to our decimal system, which counts in tens. So it's not the same number system. Even though the symbols and their conversion over here, these were all decimal from the very beginning. They were counting in tens. We are making it different, counting in fives, keep it simple, and to think about the place value system and how it works. We're used to tens. We want to change it. So we don't use all the symbols, of course, because we can't have 5. We count in groups of 5. But our other conversion task is the second half of 7.2, where I want to convert the Devanagari symbols on version of the one-hand system, the base 5 system, to decimal and back. So let's write those. And I think that would be enough information for today for you to think about. Because even though there aren't many questions right now, I believe that they do still exist. So we start with a number like this, which now I have to remember. For our purposes, this is always going to be a base 5 representation. It's coming from the one-hand system, which is counting in groups of 5. This is what we're going to use this for. So now we have to think, I want to convert this to decimal, to my modern decimal number system, which counts in groups of 10, essentially, right? So I need to remember that this is the number of ones, number of fives in my decimal language, number of 25s. So that means that I have one group of 25, because that's the one symbol, 4 groups of 5, and 0 groups of 1, giving me, use your calculator, don't use your calculator, the numbers aren't that big for most of these at least, 45, 45 in decimal, right? B. B, where's B? Oh, it's the same numbers as number 2. Oh, that's not very original. 2, 0, 0. Now, write these arrows describing what each place represents underneath if it helps you. Write more if you need it. Why not? See it there. Help yourself. Then I can see, oh, it's 2 groups of 25, no groups of 5. I still write it to show anyone who's grading this, I understand that it's what I'm doing here, what every symbol represents, and then I get a 50. Help yourself, write some stuff, show some work, so there's no doubt that you understand what is happening. Then we have the 4 symbol, the 4 symbol, the 3 symbol, and the 1 symbol. So that's now, if you want to write it from right to left and systematically chip away at the symbols from right to left, that's also fine. For some reason, out of habit, I list what all the places are keeping track of, and then I do it left to right. It's just a habit, honestly. Because I guess we read it left to right. It makes sense to me, but though you could totally do it backwards. So I have 4 groups of 125. I have 4 groups of 25. I have 3 groups of 5. And I have 1 little single. They used to be rocks, not anymore. We have evolved to something much more sophisticated. Because what this now allows me to do is to I'm recycling the same 5 symbols over and over and over. And I can have longer and longer numbers. I don't know what comes after a foot symbol. I don't need to know anymore. I'm just counting in powers of 5 and having the same symbols over and over and over. And in that way, it evolves beyond the limitations of the original one-hand system, yet still being the same thing. So maybe this is too much for you at this stage. Maybe you want to calculate it, absolutely, or do both. Let the calculator confirm what you get. Let's see. 4 times 125 plus 4 times 25 plus 3 times 5 plus 1. We get 616. And you're done. I'm just getting used to counting in 5s. Counting in 5s. And then I have one more, number 4. It's a little bit packed full of stuff today, but that's okay. Number 4, we want to convert our decimal number to the Devanagari symbols, which is now a base 5 system, counting in 5s, which means just like I did the conversion from decimal to Babylonian, I needed to see how it splits up into groups of 60. Now I need to see how this decimal number splits up into groups of 5. Well, luckily the number's not that big, so I might have a chance. And I think we've done it before, but I don't remember. They might be the same as number 1. In any case, I can have one group of 25. I'm sorry if you hear some background noise. There is construction that I cannot control. One group of 25. And then I have 12 left. So then I can fit 2 groups of 5. That leaves another 2. And then 2 ones. Is that the same as we got here? One group of 25. 2 groups of 5, and 2 ones. So we're doing the same thing. We're just not writing the hands and fingers and stuff. It's the same. It's the same underlying system. So now this means that I'm going to have a 3-place number. 1, 2, 3. It's going to be my symbol for 1, my symbol for 2, my symbol for 2. And that is the newer, more modern version of the one-hand system, a base 5 representation. That was A, I'm sorry. B, we have 128, and we know now from decimal, this is decimal, this is base 5. It is a completely different number system, though it has similarities in terms of places and stuff. The group size, the place value is different, completely different. So now I have 128. So I can, of course, make one group of 125. Then I only have 3 left, so I'll have 0 25s, but I need to address the 25. I need to address what comes next. I can't skip them. That is a requirement of my place value system. Couldn't do it in Babylonian, can't do it now. And 3 ones. So this is then going to be a 4-place number in base 5. It's going to be my 1 symbol, 0 symbol, 0 symbol. Whoopsie, I want a nice, that's actually okay. I like a nice curl at the end of my 3 symbol. That is not 1003 or anything in my decimal language. It is a different number system. Okay. Last one, we are gonna make it. What do I have here? 526. So now I need to think. Largest power of x is going to, of x, sorry, I've done too much calculus. Largest power of 5 that I can fit in here is going to be 125. And it's going to be 4 of them. And perhaps I want to say here, ooh, how much have I used already? I've used 500. Let's just put it on the side here. And I see, I need to use 26. Yeah, I can do that with one group of 25. So then I've used 525. Okay, so no 5s because I only have 1 left, and that'll be the last one. Okay. So maybe you want to keep track of stuff. Scribble some stuff on the side. That's okay. It's a conversion question. You can write whatever you want. I will then again have a 4-place number. 4 symbol for the number of 125s. 1 symbol. 0 symbol, 1 symbol. And there is the base 5 equivalent representation using the Devanagari symbols. Isn't this fun? I think so, but we can agree to disagree. So we're just getting used to, this is the same number system, different versions of it, but it's the same number system counting in 5s. It's a base 5 system. Any questions on that? Or thoughts? Or criticisms? Complaints? Compliments?
It sounds pretty good to me.
And again, everyone's different. It might take you a while to get on top of this. We are now pretty much as close as we want to be to our decimal system without just having the decimal system that we don't need to practice. We've done it so much.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.